Okay, so at this point we've already talked about how to find the area of a regular polygon, but we've only done it when you had the information that you need, the apothem and the side length, or when you had a special right triangle, and you can use those to find a missing apothem or side length. In this section, we're going to talk about what happens when you don't have a special right triangle. And the first example we're going to look at is a regular pentagon. Now keep in mind, these formulas that you're learning only work for regular polygons, not the ones that have various side lengths. So we're still going to be looking at that one triangle in the middle, and we're still going to need the apothem. Okay, but if the only information that they give us is a side length, for instance, a pentagon with a side length of 8 centimeters, then we need to find the apothem. Okay, so this is still 8, but we no longer have the 30, 60, 90 to work with. The formula is the same as what you've been working with. It's 1/2 times the base of the triangle times the height of the triangle, which remember is the apothem, times the number of sides. But we've got to do a little bit of work, kind of like the 30, 60, 90s. Okay, so we need those central angles. So the first thing you need to do is figure out how many sides you've got. And pentagon is 5. So you're going to do 360 divided by 5. Which is 72 degrees. So one of those main central angles is 72 degrees. And you've learned this already, but what happens to that central angle when you put in the apothem? It's cut in half. So you're going to do 72 divided by 2, which is 36 degrees. So this angle right here is 36. Okay, zoom in on this a little bit. So you've got a 36-degree angle. We're not using this entire side because trigonometry can only be used with right triangles, kind of like the 30, 60, 90s. So we do know what this length is. What is that? 4. It's half of the side length. So that is 4. And we're looking for the apothem A. Okay. Now going back to your trigonometry, you're going to start with the angle, and the pieces that we have as far as that angle goes are opposite and adjacent. So remember we had SOHCAHTOA to tell us which trig function to use. If I have opposite and adjacent for angle 30, that angle that's 36 degrees, what function should I be using? Tangent is opposite and adjacent. So remember the setup is the trig function, the angle, so the tangent of 36 equals the opposite, which is 4, over the adjacent, which is A. Okay, now one thing that you can do, and I didn't talk about this as much when you were learning the trig, but if you're getting mixed up with having tangent of 36 over here and having to get A by itself, you could turn that into a decimal immediately if you wanted. But if you remember what we talked about with the trig, when the variable is in the denominator, what is the quick way? You're going to switch those, because when we do all the algebra to get A by itself, A ends up over here and the tangent of 36 ends up over here. So A equals 4 divided by the tangent of 36. Now there is another option only with tangent. If you don't like the variable ending up on the bottom with tangent, you could find the angle over here by subtracting 36 from 90 and do the tangent of this angle, and it would be a over 4 instead of 4 over a. But it only works with tangent. If you end up with a variable in the denominator with sine and cosine, there's no way to switch it around. Okay, so using your calculator to find out what 4 divided by the tangent of 36 is, what do you end up with? 5.5, right? So A is 5.5. And then we can find the area by plugging into, so that's our height. Okay, so the area is 1/2 times the base of 8 times the height, which we just found, times the number of sides, which is 5. Okay, and we had a little bit of rounding here that's going to cause a difference from what you would see in the book. But basically that comes out to approximately 110. And since that was in centimeters, this would be centimeters squared. Okay, the next one we're going to do gives us slightly different information, but I'm going to flip this over so we have a little bit more space. Okay, this one has no picture. It says find the area of a regular octagon with a perimeter of 80 inches. Okay. Now perimeter is nice because the formula that you're given in the book is 1/2 the apothem times the perimeter. The problem is we still don't have the apothem, right? So you still need a side length, and you're still going to be dealing with your triangle. Okay, so octagon has how many sides? That's an 8-sided figure. If the perimeter is 80, then how long would each side have to be? 10, because it'd be 8 times 10 to get a perimeter of 80, right? So each side length is 10. Okay, now I'm going to have to figure out what that central angle is and what specifically one of the smaller ones would be. So if it's an octagon, how do I start out to get those angles? .360 divided by 8 is going to give me this big angle, which is 45. So if we drew in another one, the big angle is 45. So the smaller ones, you'd have to divide that in half, which would be 22.5. And what is this piece right here? That would be 5. And we're looking for the apothem. So, 2 ways you can do it. If you don't like the variable in the denominator, you can find this angle instead, and the variable won't end up there. So I'll do it that way just so you have those 2 options. If we subtract 22.5 from 90, this angle would be 67.5. So we would say it's still tangent because it's still opposite and adjacent, right? The only time you're not going to use tangent is if you're working with a radius. But if you're working with a side length trying to find the apothem, or working with an apothem trying to find a side, it'll always be tangent. So we have the tangent of 67.5 equals a over 5. So I'm using this angle instead to give you an alternative to having the variable in the bottom. So how do I solve this? How do I get a by itself? Yep. We're going to multiply both sides by 5. So if I multiply this out, my apothems should be 12.1 approximately. Actually, we'll keep the 0.7. Don't round too much. So 12.07. And then the rest is like what you've been doing. Area is 1/2 times the base of the triangle times the apothem, or height of the triangle. And how many triangles are there in an octagon? 8. So it'd be 0.5 times 10 times 12.07 times 8. So the area would be 482.8, and we'll say this is inches, so that would be square inches.